Okay, so we're going to look at EPQ slide. All right, so starting from the beginning here. When you're looking at the problems and you're trying to figure out what type of model you need to use, you can recognize economic production quantity when you see that a production rate is given on top of the variables that you get for EOQ. So here are some of the formulas that you'll use for this model, and I strongly recommend that you have them on your cheat sheet. And these are some of the variables from EOQ that will also be used. So here are some of the assumptions about EPQ, just some of the things that need to be in place in order for that model to work properly. So only one item is involved in the production. The annual demand is known, or you can figure it out based on what's being given. The usage rate is constant, so every time it's being used, the amount is the same. And that it occurs continually, but production only happens every once in a while or periodically. At any rate, one of the main takeaway from all this is to look for when production rate is being given. So in chapter 13, there is an example given, and it reads, a toy manufacturer uses 48,000 rubber wheels per year for its popular dump truck series. The firm makes its own wheels, which it can produce at a rate of 800 per day. There's that production rate being given. The toy trucks are assembled uniformly over the entire year. Carrying cost is $1 per wheel a year. That's one of the EOQ variables. Instead of cost per production run of the wheels is $45. The firm operates 240 days per year. Determine the A, optimal run size, B, minimum total annual cost for carrying and setup, C, cycle time for optimal run size, D, runtime. So here's some of those variables from EOQ. Here's some of the EPQ. And next to this here are what those variables represent. So for the first part, your optimal run size, you're taking that first equation from the model and plugging in these numbers here. And the order that you want to solve this, if you're punching it into your calculator a bit at a time, which I'd recommend instead of playing with parentheses, is to solve this multiplication first, do the division, do the square root of the number that you get from all this. And again, over here, you want to do this subtraction on the bottom first, do this division, find that square root, and multiply the two numbers together. You'll get that number. So that is your quantity of production. So in part B, your minimum total annual cost for carrying and setup. So your minimum total cost is your carrying cost plus setup, which involves you finding the I sub max. So in order to get that total cost, you have to solve I sub max first. And that's one of the formulas in that model, the EPQ model. So once you plug in these numbers, you end up with 1,800 wheels, which you then turn around and put back into this formula here and plug in these variables that you're used to seeing by now to form this equation, which results in $1,800, okay? So it's a two-step process for solving that part in the example. This stuff is in your book, so when I give a chapter and an example, you can find those in the book, and we'll also cover a test question, a sample test question. So cycle time is a lot more simple than some of the other equations. It's just the quantity of production which is that first equation we solved and one you're used to seeing. You have to find that number first, and you divide by the usage rate. So these are some of the numbers we've already found. 2,400 wheels in an earlier slide. And then it gives you the usage rate, 200 wheels per day. So your cycle time is 12 days. So a run of wheels will be made every 12 days. Runtime. So runtime is how long it takes to actually make them, right? So you're producing 800 wheels per day. Again, this is an equation from that model, which you should have this and every other one on your cheat sheet. At any rate, you have the 2,400 wheels that you have do in production, but you're only making 800 wheels per day. So that gives you, it takes 3 days for the run time. And I'll give you a better explanation on and even a visual on run time versus cycle time. Okay. Again, that's another simple one. So here's a sample test question. A firm produces printers. They make 30,000 of these printers per year. Each printer requires one tray that can be produced in-house. You assume a 300-day work year for daily usage rate purposes. Assume an annual carrying cost of $3 per tray. Production setup cost of $150 and a daily production rate of 300 trays. So there we see the production rate. So that should make us think, okay, this is EPQ. First part of the question is, what is the optimal production order quantity? Second part is, what is the total annual cost? So I pulled some of the numbers out of this question and matched it up with the variables that you use in that model, okay? So our demand is 30,000 printer trays per year. Our order cost per order, which in here it's called production setup cost of 150. Just think of it as the cost it's going to require to do that production run. That's how you should think of order cost per order with these. And then annual carrying cost per unit, says it right here, annual carrying cost $3 per tray. Then production rate, P, production or delivery rate, is given right here, a daily production rate of 300 trays. And then U is a little tricky because if we have a 300-day work year for daily usage rate purposes, and we need 30,000, the way you get usage rate is 30,000 trays across 300 days. It gives you 100 trays. So in just about every problem, you're going to have to understand it and pull one of the numbers out. So part A. And we're just taking these numbers that we've associated with the correct variables and plugging them into this equation. Again, from that same table of inventory formulas. Have it in the correct form and do it in the correct steps, and you'll get 2,121.32. Now, since this is a discrete number because it's units, right? That means you always round up. Even if it was 2,121.01, you'd round up to 2,122. Because if you need 0.25 of a tray, then you need to make one extra. Okay, think of it like that. So for total annual cost, again, we have to find that I sub max before we can figure out total cost, right? Like in that example in the book. So first we use the I max formula. And this number we got from the first part, okay? You need that number from this, okay? This number, this one. You need that. You need to solve it in order to plug it into this one, in order to plug it into this one. So you see this question is testing you on multiple usages of formulas. At any rate, you plug this number in. The other ones are pretty simple and easy once you've yanked them from the problem. Then you solve for this number, okay? Since we're going to carry it into the next equation, I'm not going to round yet. So now that we have this number here, I sub max, we can then take it and plug it into this equation. Once we do, so it's here now. Again, it's some of those numbers you're used to seeing over and over by now. We end up with $4,242.63, or $4,242.63 is our total cost. Okay, so that answers part B. All right, so graphing EPQ can be a little bit overwhelming. So I'm going to explain some of why this graph looks the way it does, okay? I would definitely suggest that you have this example on your cheat sheet because it's a bit more complicated than some of the other graphs. The way this is broken down, these columns of color, this orange color shows when you're producing and using the items at the same time. This beige section is when you're using them only. So you've reached a point where you have enough and you're just using them now. The run size, so the quantity that you're making, right, that is derived from this formula. The maximum inventory, so this is the highest number that your inventory will be. And there's a difference between these two lines here, okay? This is how many you've produced altogether, but since you're using them at the same time, that number is never going to be higher than your maximum inventory. That's what this solid line indicates, okay? And this dark line is always production minus what's being used. So what you actually have on hand is this dark line. This dashed line is the amount that's being made. I hope that makes sense. So you've made this many up to this point in your manufacturing plant, but you only have this many because you're using them while you make them, okay? That's what that gap here is. Now, runtime is how long it takes to make it, right? Okay. And then a cycle time is you're making and using it, and you're using it to a point where you need to make it again. So those two sections together form one cycle time. Okay. This is the sort of graph you're going to have to produce if you're asked to on one of your test questions. The x-axis here is time, so it's showing stuff happening over time. The y-axis is quantity. So I hope that this clip helps with EPQ. If you have any questions, message me and I'll try to answer, but we have 2 days before your test. So use the book, use this video, send me a question if you have one.